Dr. Lukáš Zámečník, because Lukáš was supposed to be here instead of me and then with me, but he got sick, so he didn't want to risk to travel. And I am from Olomouc, and you probably know other people from Olomouc, like Claudio or Ludmila. They are saying hi. Ludmila is currently in US, and Claudio has had some troubles, so he didn't come. So yeah. And I know that I'm standing between you and the coffee break, so this will be quick, something probably completely different than you heard till now, because this is an idea we started thinking around when I started my PhD in September, because usually Lukáš and I, we work with Turing, von Neumann, and Kurt Gödel more in cognition and AI and things like this. And we noticed that there are some patterns and some things that should be good for completing the new mechanism. So to start, there's a concept of codes in Turing and von Neumann. They're quite different and still good to use nowadays. And for Turing's, he started using code in a very different way. Since him, we are thinking about code in a computational way, with computing and other things. And he was part of the basically silent revolution in information and codes in 30s. So all started with Kurt Gödel in Königsberg and basically continued with him. Because I'm sure that you are familiar with universal Turing machine. And when he published uncomputable numbers with application to Einstein's problem in 37, he basically did something we call it Gödelization with Lukáš. And it's basically, for Kurt Gödel, he was able to represent formula in formal system by description number. It has algorithm how to do it. And for Turing, he did basically the same thing, but not for one formula after one formula, but for a whole system. If you imagine Turing machine with the reading head and possibly infinite tape and everything, he was able to represent it with something else. As is written here, we can represent the automaton by just a state table because it has its rules, it knows how to work, how to move around. So we can put it in table and know what the automaton does. And later we can put this Turing table in so-called standard description. That's usually just letters ABC. And it's arbitrary, so it's up to you. But this standard description is used even for Neumann. We're going to see it later. And it can be turned into description number. Now, you can use all kinds of numbers like Kurt Gödel, but for Turing, because he worked with computers and computing, it was binary code. So suddenly we were able to represent machine basically with zeros and ones. And it was something completely new, how to think about code. And for Turing, this means there is dual set of codes inside the one system. And it's for him, and even for Kurt Gödel, it's not a threat. It's just something interesting to point out, to talk about, will be introduced in the system, but later it's much more important for von Neumann and others' work. What's the problem with this? It's acceptability and decisiveness. Because just because the universal Turing machine can accept any sequence of code, doesn't mean that it will decide the sequence is if computable or not. But if it decides it's computable or not, it's automatically accepted as. So that's kind of a little bit something we deal as linguists, because I am from Department of Linguistics, and this is basically syntax and semantics. For von Neumann, the concept is built upon Turing's concept of universal Turing machine. Usually, when we are talking about von Neumann and Turing, we are talking about who's the father of computer and things like this, but they work together. They know each other works, and von Neumann even gave lectures upon Turing's work. And for von Neumann, the existing dual set of codes in the system is conditional, because without it, the equation under it, it's not possible. So when it comes to the von Neumann's work, it's called universal constructor, or von Neumann probes. And it's basically this. In the first bracket, you have A, that's automaton that's able to build itself over and over again, but nothing else. The B is the same automaton. It can build itself, but it also can copy the information and pass it to other automaton. But they don't work with each other because they are separate automatons. And you need C. Some authors, some scholars are thinking about C as automaton, but for me, And even for von Neumann, it was more about function, that you have this control function and it's giving rules to A and to B where to start their work. And of course, this is just a physical copy. You can imagine as a robot in an aquarium with hand, with all equipment. But you need the information as a second bracket. This is this again, but just written as a standard description as a code, put inside basically the physical automaton. And it has its own information about itself and what to do with itself. So when we give it, now you can start work, it's going to build itself and it's going to pass the information about itself in the new automaton. So we have self-replication. But von Neumann wasn't able to finish one thing, and it's evolution. These two standard descriptions weren't done by von Neumann, but by Haber-Patti. And here you can notice that in the first bracket we have still the same automaton. But in the second bracket, in the information, you have D, suddenly something new. We can think about D as a tabula rasa. It's completely blank. It's a space in the automaton and can be used in any way. It's up to us what we're going to feed it, the automaton, and what we're going to use for it. So in the new automaton, it can still behave like the first one, just have the space for the D, just in case. But if you give this automaton information from outside, that something is happening, something change in the surrounding, it can evolve. It can include a D in the new code, and it's pass the D to the new automaton. With this, again, there is a paradox in representability and constructability. Just because you can represent something by something else doesn't mean that this automaton on you can construct it. But if you can construct it, you can represent it. So this is kind of what we are working around. And we are trying to introduce it basically back to the new mechanisms. Now here you can see one of the three most cited definition of mechanisms, that are entities and activities organized such that they are productive or regular changes from start to setup to finish or termination condition. And this is basically, it's very famous and one of the crucial part of new mechanism. And its talk is basically how Turing's machine works and things like this. And it talks about that we need mechanisms, and to understand the mechanisms, we need models. In the quote by Maynard Smith, we understand biological phenomena only when we have invented machines with similar properties. We can basically immediately cross out the biological, but we need models to understand phenomena. This is what new mechanisms is about. It's a definition of the universal mechanism, the old one from Descartes, but it has certain loops to just fit kind of everything and to work around certain definitions. And the really important role are the models. Without the models, there is no new mechanisms. But the problem is, for people like Glennon, who's other important philosopher in this new mechanism, for him it's not possible to accept thought experiments such as Turing machine and von Neumann universal constructor as the models for new mechanisms, because they are not real. And the main problem is that UTM operates with possible infinite tape. Now, it's really good to read the original work, because Turing usually said that there is a possible infinite tape. You don't have to have the infinite tape. That's the reason why Chomsky could work with this for his grammar and things like this. But usually we thought about UTM with infinite tape. And because UC is majorly based on UTM, there is a problem. We can, according to Glennon, accept it as a model because it's not real and it's work with something really strange. And it would be easy to do this, that it can be accepted as models for certain programmed functions, because in the end you can write Turing machine and universal constructor as code and use it this way, but it's not satisfying enough. So we thought with Lukács to apply the extended mechanism by Professor Barbieri, and on its own, extended mechanisms trying to introduce meaning into mechanistic philosophy. And here is an expert from Lukács' paper, and I believe it was a private conversation between him and Professor Barbieri in 2020. And it's basically saying that we need, by introducing meaning as a fundamental component of life and new observable, just as molecular biology has introduced the new component information, that we need the meaning inside the mechanism. And the new mechanism philosophy was trying to do it, but in a weird way. But he also proposed something more complex for the mechanism, because usually in the new mechanism, we have many definitions, and there are various for what they want to do with it. But suddenly we have this, and we are sure that the new mechanism is not reduction, it's not determinism, and it's not physicalism, but it is modeling. As a method, it's a scientific modeling. And models in this case these are basically the same things over and over again, saying differently. But we need the models to understand what means the world around us. And what's important for us, model does not have to be physical or realistic in the extended mechanism. So suddenly we can work a little bit more with Turing machine and von Neumann probes and things like this, because map is not the territory. And it's something quite interesting. And the question is, what about UTM and UC in this context? So when it comes to the UTM, Turing's work, this is accepted as same as Gödel's proof is accepted as a model, a mathematics model. But with UC, it's quite complicated, mostly because it's taken as an interesting concept and historical milestone in the science. Also, if you Google von Neumann probe, you're going to get to the Reddit and to the weird guys, and they will say that they built it. So it's part of the sci-fi and part of the culture, mostly not exactly the science. And usually people are very careful about using UC as a model, because there is always something missing or something a bit weird about it. For me personally, and even for Lukáš, is a problem of lower threshold. You can know it from the work of Umberto Eco in semiotics, and the problem is that UC has the potential to cross the boundaries if you don't set up them right. If you don't give it the right rules, it can be weird in semiotics, and it can be weird around biology and things like this. So you need to set up the boundaries right. And one of the way how to do it is the separation of UC as a universal constructor from the cellular automaton. Now, when you read von Neumann's work and the papers about it, they are usually taking universal constructor and cellular automaton and self-reproduction automaton as a synonym. But we can separate it. We can have the cellular automaton, the A plus B plus C. But we can, the UC is basically program. It's a configuration on 29 states in cellular automata. So we can take it out of it and use it more theoretical way, like this. So in conclusion, and I promise you it will be very quick. In conclusion, UTM and UC as theoretical model, and not only a new mechanism, it's a question. I'm young, I still have time to tinker about this idea and others, so I'm not bold enough to say that we can apply it exactly in code biology and in biology, as usually people like Harapati are saying, that we can use it as a molecular machines. But there is still a way how to introduce these concepts back. Because in the end, Turing was not only a logician and mathematician, he also did some things with biology, and from embryology in 52 to genetic algorithm in 54 in his essay in chess. And he was thinking about code more in organic way. If you read his machinery and intelligence and other papers like this, he's not talking only about machine learning and neural networks. He's connecting the codes into that, and he's basically talking about artificial life, but not in the same way how they usually do it in the program. It could be used as a model for evolving universality, because some people have problem with that in the moment the von Neumann probes start evolving. They are saying it's not universal enough anymore, because it's not the same concept as it started with. And I know this is quite bold, but it could be great connection to artificial life program, because right now it's separated from biology and from other, and we are actually more using AI with ChatGPT and everything. But ALF is still working with cellular automata. They are still working with the work of von Neumann in quite wonderful way. Not only the game of life that it was in the last century, in the 90s, but with other many things. And it would be interesting to use the models in ALife for code biology and to understand what's happening around us. Now, I'm a linguist and a historian, so everything around biology and chemistry is kind of like over my head. But this is something really interesting. There are some recognizable patterns. But what's the most interesting thing? New mechanism is kind of not working for biology. It is supposed to be working for biology. It started with biology because other science, formal science like physics and mathematics, they own the mechanism, the classical mechanism is working for them. And the new mechanism was supposed to be for biology, but it's not working quite well. So in the end, we just trying to introduce not only these two models, but also saying that the extended mechanism might be the key, not to just to introduce the models in, but to accept the new mechanistic philosophy in the biology, and co-biology, and biosymmetrics, and other theories around. So, thank you for your attention. I know it was something completely weird. Please don't kill the messenger.
No. Doctor, yeah, right, first.
Okay, shall I go first?
Yeah.
So, thank you very much. This is, of course, something that is very close to my heart as well. So, von Neumann had two models. He had the kinematic model and he had the cellular automata model. And of course, if you want to connect the von Neumann type of architecture of a universal constructor to biology, it's been the cellular automata model is not going to help you. The kinematic model is going to help you because that it's supposed to be something that is implementable in terms of real stuff. And it may be of interest to you that, I mean, I've been thinking about it for a long time, and I've published two papers, one called Causalities, Constructors and Codes, in which I show how one can model the von Neumann kinematic constructor in terms of category theory. And then I've shown in a later paper how actually in the cell there is a kinematic, what I call a distributed von Neumann constructor. But the cell is basically a von Neumann constructor, and the whole architecture you can actually model inside the cell. So it may be of interest to you to have a look at those papers and see in what way you can connect what you're doing. Because what you want to do in the end is understand not artificial life, you want to understand life.
Yeah, exactly.
Yeah. And so you have to be able to connect, to realize your models in terms of real stuff, in my case, the biochemistry of the cell.
Yeah.
So we can talk afterwards, but I'd really like the work.
Yeah, this is actually still developing. I started my bachelor thesis with the Lauer threshold and von Neumann probe, and my master thesis was about the role of von Neumann probe in code biology. And I'm still not exactly I'm not sure that the cellular automaton is working. It's not. It was said many times, and to say that it's it's insane right now. Yeah. But there is still something about it, just tinkering inside the mind, just to work the way around it and understand the theory more and do it this way.
Yeah. Good luck.
Thank you.
But we'll chat. I'll have to chat to you later.
Okay, I'm just giving some feedback. You're young. I've been doing this for 30 years, so...
This is my first.
Yeah, exactly. So this is... I don't know if you know the modeling relation of Robert Rosen, because I think this is crucial. Yeah. This is the starting point. Second, I don't know if you know the ghost in the machine of Arthur Koestler. Yeah. That is, what is the meaning, the emergent properties behind mechanisms? Because you want to do extended mechanisms. I don't know, because like this artificial life, if you unplug the computer, it's over. It is like all the 8 different codes that you have in the genome. You put it at pH 1 and there is no code. It is always important to be aware that you have a thermodynamic side, a tangible side in which all these things happen. So your construction of models, whatever, always have to be related to the fact that these things have to be realized and they will have to be feasible and viable where they will be instantiated. No, so fantastic. I fully agree on what you are trying to do, but I would say try to expand a little bit because there is life beyond von Neumann things. Because there's exactly the same things you may have with the biosemiotic, because at the end, the bottom line, you have to do a functional cycle in which the model is instantiating itself in a realization. They redo the model and trying to have, because this artificial intelligence now we are changing everything. We are now producing food, transporting stuff exactly like 100 years ago.
Yeah.
Artificial intelligence didn't do anything as soon as you get into the tangible part. So we have to be aware that unless you are considering the two sides of the story, we can go too far into the notional part, and maybe you start losing usefulness in relation to what you want to apply later on.
Yeah.
This is an old guy.
No, thank you very much for it.
Well,
Any more questions? Thank you for your presentation.